Today we're going to be talking about 1.5, subtracting rational numbers. Now just remember, a rational number is anything that can be written like a fraction. So today we'll be dealing with a lot of fractions and decimals. I want you to write this down. We have talked about this quite a few times, and it's just the rules that we want to remember. Same sign, add the numbers, keep the sign. Different sign, subtract the numbers, and take the sign of the larger number. So we've done this with integers, which were our whole numbers, but the same exact rules are going to apply now whenever we have decimals and fractions also. For these first few questions, it asks us to find the difference and then write the fractions in simplest form. There's one thing we've got to notice about problem A. Who can see what's the first thing I should do? Kaylee. We have a double negative. So, class, what do I do to the double negative? Make it a positive. Okay, so now I'm just going to go ahead and rewrite that, and I've got 1/3 plus 1/3. The hardest thing about adding and subtracting fractions is making sure you have the same denominator. Do I have the same denominator? So this is pretty simple. What's 1/3 plus 1/3? 2/3. And that's it. That's it. All right, because we already know our rules, this should not be too difficult. Let's go on to the next one, problem B. This is a little bit more difficult because what kind of a number is that first number? It's a mixed number. How can I make that look like just a fraction? What do I do, Connor?
3 times 3 plus 1.
And what do you get?
10 over 3.
10 over 3. Okay, so is that it for that part?
Yes.
Bring down the negative. That's what tons of people forgot to do on their test. If there's a negative right there in front, you have to once again bring down that same negative sign. Now let's keep going. You're going to bring down the minus sign and bring down the 2/3. Do I have the same denominator? Yes. So whenever I have the same denominator, my answer is going to have the same denominator because I'm just working with thirds. So right now, remember the saying that we've said many times. Every number has a sign, and that sign is directly in front of that number. So do I have the same sign or a different sign? Same sign, add and keep. So what is 10 plus 2? And keep the sign? Negative. Can this be simplified at all? Yeah. What is negative 12 divided by 3? Negative 4. Thank you for remembering to say negative. So that is your answer in simplest form. Problem C says 4 minus 5.5. How can I make that 4 look like a fraction? 4 over 1. Okay, so I'm just going to simply rewrite that as 4 over 1. Bring down your minus sign. And now how can I make 5.5 look like a fraction? What do I do? 5 times 2 plus 1. What do you get? 11 over 2. Am I ready to subtract now?
No.
What do I have to do?
Multiply the 1.
I got to get those denominators the same. So let's multiply the 1 by a, and whatever you do to the bottom, you also have to. Good job. So what's my new fraction right there? 8 over 2. Bring down your minus sign and bring down your 11 halves. Once again, same rules apply. Same sign, add and keep. Different sign, subtract and take. Do I have a same sign or a different sign? Different sign. So we're going to subtract and take. Sometimes it's just easier for people to go ahead and just stick the denominator there because we know it's going to be a half. And then you can just look up here at the top. 8 minus 11. 3. And then take the sign of the larger number? Negative 3. Can I simplify negative 3 halves at all?
Negative 1 and 1 half.
Very good. It would be negative 1 and 1 half. Now sometimes people say, I don't understand how you got that. If you look at this right here, all you're doing over here is you are going 3 divided by 2, and when you work that out, then that's going to get 1 and 1 half, and you keep the negative. Okay? Any questions on how to do those first 3? All right, here we go on to the next one. Now we're working with some decimals. Decimals are the same idea. Do I have the same sign or a different sign? Different sign. So we're going to subtract and take. Whenever you're subtracting, you have to put the biggest absolute value on top. What's the biggest absolute value? 2.4 or 5.6? 5.6 is the biggest, so we're going to start with a 5.6, and now we're subtracting 2.4. When you subtract that, just the girls, what do you get?
Negative 3.2.
Okay, 3.2, and I heard a lot of people say negative. Good job. Because that was the larger number, this right here was negative, you want to keep that negative sign. Who would like to do problem E for me? All right, Maddie, try it out. What's the first thing I have to do?
Make the double negative a positive.
Good job. We always want to identify those double negatives. And now let's just go ahead and rewrite it. Negative 8.8 plus 8.8. Do you guys see what kind of numbers those are? They're opposite numbers. One's a positive, one's a negative. Do you remember, like negative 5 plus 5, what does that equal?
0.
0. Negative 20 plus 20?
0.
0. Negative 50 plus 50?
0.
0. So what do you think negative 8.8 plus 8.8 is?
0.
0, okay? That is a number and it's opposite. If you remember a few days ago, I told you the mathematical term. It's called an additive inverse because you're adding inverses or you're adding opposites. Anytime you add the opposite number, it will always equal 0. Let's go on to the next one. Do I have the same sign or a different sign? Different sign. So what do I do when I have a different sign? Subtract and take. Let's look carefully at this. Which one of these numbers is bigger?
0.5.
Okay, listen, if you can't figure that out, I know this has two numbers, so sometimes we might think that's the bigger number. But I could add another number behind that 5. What would it be? It would just be a 0. So if you look at that, 0.45 is smaller than 0.50. So we're going to put the bigger number, the one that has a bigger absolute value, on top. So which number goes on top?
0.5.
Okay, 0.5. Now, if you have that 0, you can keep the 0 in the front there, or you can just get rid of it. Now, since we have different signs, we're going to subtract and take. I want you to do that on your own. What is the correct answer?
Negative 0.5.
Okay, so we've got 0.05, but you want to keep the sign, so it is negative 0.05. Any questions on that? All right, let's go on to the next one. Kalani, same sign or different sign? All right, every number has a sign, and that sign is directly in front of that number. This is a negative in front of that number, so they are different signs. So I've got to subtract. Which one's the bigger number? 4.9. 4.9 goes on top, minus 1.6. Kalani, what do you get? 3.3, and is that positive or negative? That is a positive 3.3. All right, any questions on how we just added and subtracted fractions and decimals? All right, let's go on to the next one. This next part I'm going to talk to you about is called commutative property. Everyone say commutative property. Okay, so these are really big words, but it does not have to be big and scary. Let's talk about commute. How many of you would say, if I say I have a commute to work, you know what I'm saying? What's a commute mean? How far you go, okay? If I say that my commute was very long today, that means my drive was very long today. When I am driving, I am moving myself from one place to another. Commuting just is moving something from one place to another. So guess what commutative property is just saying you are allowed to move numbers from one place to another. It's kind of like taking a little shortcut, and it helps us to do something faster. So if you look right here inside the car, I have this right here, 3 plus 4. What is 3 plus 4, guys? 7. So now you can see this next one. What happened to my numbers here in the second truck? They switched, okay? The first order says 3 plus 4. This one is switched, 4 plus 3. What is the answer to 4 plus 3? 7. So what the commutative property of addition says is you can add numbers in any order and it will not change your answer. So when you are commuting, you are driving or moving to a different place, commutative property simply says you can move the numbers around without changing the answer. So let's go ahead and do a few examples like this. We're using the commutative property, or the property that tells me I'm allowed to move numbers around, to solve the expression. Does anybody see a number that you think should be moved around in my first example?
No.
What do you think? What I want to do is I want to put a number and its opposite next to each other. So I'm going to drop down the first number I have, -2, and now I'm going to switch the last two numbers. Now remember, every number has a sign, and that sign's directly in front of the number. So if I am moving the 2, I have to take the sign with it that's there. So I'm going to move to +2, and I switched it with this one right here to +5. Now, I want you to look at this first thing right here. -2 + 2. Do you guys know what that equals?
0.
0. So underneath it, I'm going to put 0, and then I have to drop down what? +5. What's 0 + 5? 5. So because of the commutative property, I was able to switch some things around and easily find my answer. Let's look at the next one. Sometimes people get scared whenever there's fractions, but it doesn't have to be a scary thing. Who can help me to know what numbers you think I should commute or I should move around? What do you think, Aubrey? Okay, very good. So we're going to do the first one, 1/5. Now I'm going to switch the other 1/5. Should I take the sign with it? Yes, because that sign, this is attached to that 1/5. So now I'll do -1/5. And then I'm going to take that sign with this one, plus 3/4. What happens when I have 1/5 minus 1/5?
0.
It just becomes a 0. Listen, if this makes you happy, you can just cross it out neatly and put underneath it 0 plus 3/4. Aubrey, what's my answer? 3/4. So the commutative property allowed us to move some numbers around to find the answer a little bit easier. This next one, let's look at problem C. What is the first thing I should do before doing anything else?
Fix the double negative.
Fix the double negative and turn it to a positive. Good job, Maddie. Now I'm just going to go ahead and rewrite everything, but I only need to write that plus sign one time. Now, when you're adding, you are allowed to add from left to right. If that makes you the happiest, that's totally fine. If you want to commute or use that property, you can switch things around, but you don't have to. Sometimes people just like to work from left to right. In this case, I'm just going to work from left to right. Now, I do not care if you want to, on the side, do this math here on the page, but how many of you would say that to you is math that you could probably do in your head? Sometimes we like mental math, and some people like to do it on the side. I don't care how you do it. But if we were to do this in our head, we're going to take this right here. What is 8 minus 3? 5. And then I'll put my point. And what is 7 minus 3? 4. Okay, so you can do 4.5 right there. That was mental math. If you like better to do it over here on the side, that's fine too. Now I'm going to drop everything else down in my problem. Plus 1.2 plus 4.3. Let's keep going. Once again, I'm choosing not to use commutative property this time. I'm just going to work from left to right. What is 4.5 plus 1.2?
5.7.
5.7. So I'll drop that down, plus 4.3. Now, once again, if you say, I am not that quick to do mental math in my head, you can do it on the paper or you can slow it down, all right? Now I have the final one. Once again, some people are saying, I like better to do it here on the side. Go ahead and do it on the side if that is better for you. On the count of 3, I want you to tell me what our final answer is. 1, 2, 3.
Positive 10.
All right, 10. So listen, when you were adding that together, you actually found 10.0. But in order to simplify that or make it as simple as possible, that's just plain old 10. All right, so once again, you can use the commutative property, or you can just do it from left to right. I do not care how you find your answer. This is not something that's new to us. This was actually on your test yesterday, but I want to review it and go over it again. It says to find the distance between two numbers on a number line. Find the absolute value of the distance of the numbers. So that means you cannot have a negative distance. Yesterday on your test, many people tried to tell me that you went -2 miles. You cannot go in a negative way. It just means you ran 2 miles. So let's talk about this right here. I taught you something special, how you could know how to figure out the distance between two numbers. I told you you have to take the biggest number and subtract the smallest number. Let's look at this right here. I don't want you to tell me what the absolute value is that's biggest, but what number is bigger, -3 or -7?
-3.
Okay, I heard both answers. Think about money. Would you rather have -$3 or would you rather have -$7?
-3.
You'd rather have -3. So tell me again, which number is bigger between the two?
-3.
-3. So we're going to take our biggest number and subtract the smallest number. What's my smallest number?
Negative 7.
Not 7, but -7. You have to remember every number has a sign, and that sign is directly in front of that number. What happens now?
Change it to a positive.
Change that to a positive, and now my new equation is going to say -3 plus 7. Different signs, subtract and take. What do you get?
4.
4. All right? A lot of people on their test told me -4. Remember, there is no such thing as a -4 distance. Now, I want you to use the number line up there because this might help you to visualize it a little bit better. If I put this on -3 right here, and I put this on -7 right here, it is 1, 2, 3, 4 numbers away from each other. So the distance between them is 4. Let's do another example. Going over here, problem B. A lot of you might look at that and be like, I know the answer right away. If you feel that way on the count of 3, I want you to tell me the answer. 1, 2, 3.
0.
All right, I predominantly heard people say 0. So let's just think about this. It is not asking you to add together 5 plus -5. If I wanted you to add 5 plus -5, that would be the truth. But what I have asked you is to take the biggest number and subtract the smallest number to find the distance. What's the biggest number between those two?
5.
5. And subtract the smallest number. What's the smallest number?
5. Negative.
Not 5, -5. What do I have now?
A double negative.
A double negative. So what do I actually need to do to those numbers?
Add.
Add them. Guys, what's 5 plus 5?
10.
10. Once again, you can use a number line to help you. If I draw out a number line and I have here a 5 and I have a -5, many of you just told me it would take me 0 hops to get to the -5. That doesn't make sense. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So think carefully. I am asking for the distance. I'm not asking you to add the two numbers together. So I want you guys to try problem C on your own. All right, I just walked around and saw a ton of great answers. Tell me, what's the biggest number?
7.
-7.6. And then you have to subtract the smallest number, which was
7.6.
-14.2. What kind of a problem do I have?
Double negative.
Double negative. Same sign or different sign? These are different signs, so what do I have to do? Subtract and take. If I do it over here, 14.2 minus 7.6, what do I get, guys?
6.6. Yes.
What did I do? Oops, this should be a 3. There we go. 6.6, positive or negative?
Positive.
That is a positive 6.6. Who got that correct? All right, if you didn't, does anyone have a question for me? Okay. This is tonight's homework for 1.5, so go ahead and write that down on your piece of paper for me, please.